Okay, you're using Unit 3, Lesson 2 to help you. Horizontal rows on the periodic table are known as use Unit 3, Lesson 2 to help you. Gunnar, those pages are what? 128, 129? Yeah. Okay, guys, 128, 129 will be very helpful. Horizontal rows are known as periods. So, horizontal rows, side to side. Same two pages. Vertical columns on the periodic table are known as groups or families. Okay. Vertical columns go up and down. All right, the next question says, what do elements in the same row have in common? That doesn't work for me. Okay, what are the only two elements in row 1, guys? Hydrogen, and way over here, helium. Okay, it just so happens that they only use one energy level to place their electrons. That's what they've got in common. Okay, everybody in row 2, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. How many energy levels do they have to have in order to place all of their electrons? Got to have 2 energy levels. Everybody in row 3 has to have how many energy levels? 3. Everybody in row 4 has to use 4 energy levels, so on and so forth. Has everybody got that? Okay. Hang on. All right. So what do elements in the same horizontal row have in common? All right. So the same row, remind yourself that that is periods. So they use the same number of energy levels for their electrons. Straighten that up a little bit. Okay. What do elements in the same vertical column have in common? This one actually is in your lesson, this answer. There you go. So the same vertical column is the same group or family, and everybody in the same vertical column, they have the same number of valence electrons. Okay, so for instance, hydrogen, lithium, sodium, potassium, all these guys in the first column, column 1 or column 1A, they all have 1 valence electron. Everybody in column 2A has 2 valence electrons. And because you guys are only in 8th grade, we're going to kind of ignore the short columns because remember, we're not learning everything about chemistry. We're just learning the basics. Short column is a little more complicated, so let's go back to the tall columns. Column 3A, or sometimes called column 13, how many valence electrons do you think they have? 3. Everybody in column 14, otherwise known as column 4A, how many valence electrons? 4. Everybody in column 5A, 5, etc. Do you guys get the picture? So everybody in the same vertical column, everybody in the same group or family, they're going to have the same number of valence electrons. And that's going to give them similar chemical properties. That's important. All right, Unit 3, Lesson 2, page 127. Dmitri Mendeleev arranged the first periodic table in order of increasing atomic what? Mass. Later, Henry Moseley arranged the periodic table according to increasing atomic number. Remember that atomic number is the number of what? Protons. And some of y'all might be thinking, well, it shouldn't make a difference. It actually does in a couple of places. If you look at your periodic table that I gave you, and if you will find cobalt and nickel right here. If Mendeleev arranged the periodic table according to atomic mass, cobalt and nickel would be switched. Do y'all see that? They're where they are now because we arrange it now according to increasing atomic number. But there were some places where we had some problems. Do what? What? Next question says, why are the lanthanides and actinides placed below the periodic table? Okay. So, these guys, the lanthanides and actinides down here, they're called the lanthanides and actinides because this row starts with lanthanum, this one starts with actinium, but all of it fits in here. But in order to make it fit, you'd have to cut the periodic table right here, and you'd have to move it apart, and you'd have to stick all those in there. Okay? What does that make the periodic table? It makes it a little too wide. So, why do we put them where they are?
So we can make it narrow.
Yeah. Okay, it fits better on a piece of paper if we make it a little more compact. Okay. All right, guys, let's fill in this table down here. Chlorine has a chemical symbol of Cl. Mass number. Round it off, it's 35. Atomic number, 17, which means it's got 17 protons. And as long as it's neutral, it will also have 17 electrons. How do I get the number of neutrons? 35 minus 17, which is 18. And then I need to take my 17 electrons and I need to place them in their energy levels. I always fill the first before starting on the second. I always fill the second before starting on the third. How many electrons can I put in the first energy level? Only 2, and then it's full. How many electrons can I put in the second energy level? 8. And then it is full. So I have placed a total of 10 electrons so far. How many am I left with? 7. Those final 7 go in the third energy level. How many valence electrons do I have? 7. It's just whatever is in the outermost energy level that you used. That's it. By the way, I don't think anybody needs to be on their Chromebook right now, so please shut those lids. Thank you. All right, Na, what does that stand for? Sodium. It is sodium. Mass number. Okay, it was 22.99 is the atomic mass off the table, so what do we do with it? Round it to 23. Atomic number? 11, which means we have 11 protons, and as long as it's neutral, we also have 11 electrons. How many neutrons? 12, because 23 minus 11 is 12. And then I have to take those 11 electrons and place them in their energy levels. I can put 2 in the first energy level. I can put 8 in the second energy level. How many go in the third energy level? Just 1. How many valence electrons? Just 1. All right, oops, sorry. Lithium is next. Capital L, lowercase I. Take the atomic mass and round it off. What do you get? 7 is the mass number. Atomic number? 3. Which means it has 3 protons, and as long as it's neutral, 3 electrons. How many neutrons? 4. Take your 3 electrons and put them in energy levels. 2 can go in the first energy level. 1 will go in the second energy level. Anything in the third? No. How many valence electrons? 1. But Ms. Goff, what about the third energy level? It really just doesn't even exist because we didn't use it, right? Not on this one. Why did I do sodium and lithium in the same color? They have the same number of valence electrons and they are in the same vertical column. What do you think I'm going to do with fluorine? Do it in the same color that chlorine was. Why? They have the same number of valence electrons, as we are about to find out. Okay. Fluorine's mass number? 19. Atomic number? 9, which means fluorine has 9 protons. As long as it's neutral, 9 electrons as well. Neutrons will be 10. And now I have to take those 9 electrons and put them in energy levels. Put 2 electrons in the first energy level, 8 in the second energy level, and that last, oh, I'm sorry, I lied, there's only 7 there.
I got confused, I was like,
Sorry, that was me. That was me just cruising along, filling in electrons. Okay, so there's only 7 in the second energy level. How many valence electrons? 7. Okay. So based on the table that you just filled out, why do you think sodium and lithium are in the same column? Same number of valence electrons and therefore similar chemical properties. Oops. Why do you think chlorine and fluorine are in the same column? Same number of valence electrons and therefore similar chemical properties. All right, so just make sure that you've got those answers written in and then put that in your binder for notes.